This video is formula of a hydrate, and this is for the second part of our interpreting formulas unit. Okay, so we have to talk about what we think the word hydrate means. As soon as we hear the word hydrate, we usually think of like hydration, like someone is dehydrated, they need extra hydration. And so that would mean adding water to the system. And so hydrates are going to be based on this idea of water. We're going to be on maternity page 117, formula of a hydrate. Our state standard is still P.8.9 because we're still interpreting formulas. We have three questions. What is the difference between a hydrate and an anhydrate? What is the mole ratio needed to determine the hydrate? And then how do you name hydrates? And so we're going to go through all of those steps today. So before we kind of do anything, we have to talk about the words hydrate and anhydrate. And so I'm going to use an illustration to show you that. So if we start with hydrate, the word hydrate is a compound plus water in a set ratio. So if our compound are these things here in blue, then, and the reds are the waters attached to them, we can see that the ratio is 1 compound for every 3 waters is our hydrate ratio, and they always are in set ratios. Hydrates are compounds that hold water in them, but they don't necessarily look wet. So if you think about the little packages that show up in like shoes or beef jerky, those are usually compounds that like to be hydrates. So they're going to absorb water out of the package in order to keep the things fresh that are there. And they do that so in a set ratio. So hydrate is a compound plus water in a set ratio. So in lab, what we do is we take a compound and we can find out this ratio that they're going to be in doing an experiment. And so we start out by just taking our compound and our water, putting it in a dish and putting it on a hot plate. So we've got our hydrate because it's the compound and water together. But again, it does not look wet. It looks dry. It's just attached, small amounts of water attached to it. We're going to put it on the hot plate, and so what it's going to cause to happen is the water is going to evaporate, or it's going to be lost to the system. Now we know that mass is never truly lost. It's just not easy to measure. So if we know how much compound we started with, once that compound is completely dry, we can figure out how much water was lost or evaporated. At the end, the compound we have left over is called an anhydrate. An is a prefix that means without, so without water or dry compound. And so to find our formula of our hydrate, we're going to look at the relationship between water and anhydrate. And we're still looking at mole relationships, so it's going to be kind of similar to what we did with empirical and molecular formulas because we're going to be doing a mole ratio. Okay, so we kind of have to understand these terms. So again, this is that wet compound that we heat up so that the water evaporates or is lost, and then what's left over is the anhydrate or the dry compound. If we know the mass that we started with and the mass that we ended with, if we subtract those two values, we can figure out how much water escaped, and then we're going to use some mole ratios to get that done. So the anhydrate, again, is the dry compound with no water in it in comparison to the hydrate, which has the compound and water. So the difference between the two here is water. So if the hydrate is the water and the anhydrate together, or that compound, the anhydrate would then be the hydrate minus the water, and the water is going to be the hydrate minus the anhydrate. The only two we actually care about are the anhydrate and the water values. The hydrate just helps us get there because we're going to use this information, or the mole ratio, to figure out the formula of a hydrate. Okay, so now we have an idea of what we're talking about. Let's go ahead and work through our notes. So hydrates and anhydrates. The first thing we need to know is that a hydrate is a compound with a set ratio of water attached. So a hydrate has that set ratio of water attached to each unit of the compound. And if the compound is heated until no water is remaining, until all that water evaporates, you're left with the anhydrate, because the anhydrate is, again, without water. So that water is lost to the system. So what we're going to do is we're going to use the mole ratio in order to discover this. If we know the mole ratio between water and anhydrate, then we're going to be able to calculate the formula of the formula of the hydrate. But we have to have the ratio between water and anhydrate. So we have 5 steps to do. The first thing is we're going to, after we read the problem, find the number of moles of water from grams of water. Then and that's grams of water we're going to determine from the problem. Then we're going to find the moles of anhydrate from the grams given in the problem. We're going to have to use the periodic table for that. So we need our moles of water, We need our moles of anhydrate. Once we have those two values, then we're going to just divide. And so we're going to take the moles of water divided by the moles of anhydrate, and we're going to round that to a whole number. And then that whole number is going to go into our formula. And so our formula is going to be the name of the hydrate plus NH2O. N is that whole number that we just got because it tells us our ratio. And then we name it. And so we'll name the compound, and then we'll use prefixes like mono, di, tri, hydrate. So if this N was a 3, we would say trihydrate. If it was a 4, we would say tetrahydrate. Just to remind ourselves, anhydrate is the hydrate minus the water. Water is the hydrate minus the anhydrate, and it's often called mass lost because that's what evaporates when we think about our picture. That water is what's evaporating, so it's what's lost to the system. Okay, so let's try a problem. Our problem says a mass of 3.500 grams of copper 2 sulfate is heated to reveal 1.59 grams of white powder remaining. What is the formula of the hydrate? And so we have to start out by looking at lots of information here because we've got to get, ultimately, we need to know the moles of water divided by the moles of anhydrate. That's what we need to get to. And so we've got to start with, well, what's in our problem to begin with? So I see that a mass of 3.500 grams of copper 2 sulfate is heated. Normally the thing that is heated is the hydrate. So this amount here is going to be our hydrate. And it's heated to reveal 1.59 grams of white powder remaining. So that's what's left over after the reaction. Well, we just learned that what's left over after it evaporates is going to be the anhydrate. So the question is, well, how much water is there? Well, if we look back on our notes, we know that water is going to be the hydrate minus the anhydrate. So we're going to take, for water, we're going to take the hydrate amount, 3.500 minus the anhydrate amount, 1.59, and that will give us 3.500 minus 1.59 is going to give us 1.91 grams of water. Okay, so again, all we really care about is the moles of water and the moles of anhydrate. This hydrate amount doesn't matter to us. So let's start with the the water amount, because the water is the easiest one to deal with. So we know that we have 1.91 grams of H2O. Our very first job is to turn it to moles. If we think back and we look back at our notes, we've got to know the moles of water from the grams of H2O. So we've got to take these grams of H2O, and we're going to add up H times 2 plus O from the periodic table, and we're going to get 18.015, which is a number that you're going to memorize because we're going to use it so much. So we take 1.91 divided by 18.015, and we're going to get, again, we're going to go to 3 places after the decimal. So 106 moles of water. And now we need to do the same thing, but for our anhydrate. Okay, well, that's going to take us a little bit more work. So we know that we have 1.59 grams, 1.59 grams, but our compound is copper 2 sulfate. So we're going to bring in some review. This 2 means that copper has a charge of +2, and sulfate on the back of our periodic table, when we look at sulfate, we see that it's SO4 -2. Well, +2 -2 gives us a 1-to-1 ratio, so it's just CuSO4. So CuSO4. So grams of CuSO4 come down. 1 mole comes up because we're just, again, finding the moles of this. So I'm going to have to add up the mass of CuSO4. So I'm going to start by saying, well, oxygen is 15.999 times 4, plus sulfur, which is 32.066, plus copper, which on the periodic table is not that, 15.999 times 4, plus 32.066, plus 63.546, gives me 159.608, 159.608, and so I'm going to take 1.59 divided by 159.608, and that's going to give me 0.09 9, in this case I'm actually going to go 4 places after so that I don't have to deal with the 0.99s, moles of anhydrate. You can always go farther than 3 places after, just don't go any less than that. Okay, so now I have my moles of water and my moles of anhydrate. So my next step is to do this formula, moles of water divided by moles of anhydrate. So I'm going to say 0.06, 0.106 moles of water divided by 0.0996 moles of my compound, CuSO4. And so I'm going to type that in the calculator, 0.106 divided by 0.0996. And that rounds to that gives me 1.06, which is really close to 1. So this is my N. I know that my formula is now going to be CuSO4 with 1 H2O attached to it. CuSO4 with 1 H2O attached to it. And so the name of that would be copper 2 sulfate, which we got from the name, monohydrate. And again, mono because there was the 1 there. All right, so let's just kind of review what we did by looking back at our notes and kind of going through the steps. So we need to know the moles of water divided by the moles of anhydrate. We know that the moles of water are what are lost in the problem. And so each time you have to read the problem very, very carefully. It's really easy to get these mixed up, not because the math is hard, but because reading the problem sometimes is hard. Whatever we're starting with is always going to be our hydrate. That's what goes onto the hot plate. Whatever we're left with after the fact is our anhydrate or our dry compound. The difference between the two is our water because that's what was evaporated, and it's usually harder to measure that. So we have to subtract the two values in order to get our difference. And so we got the 1.91 grams of H2O. We then take just the anhydrate and the water. That's the only parts that we care about here. So we need the water amount and we need the anhydrate amount. This actual hydrate amount is not used once we have done, once we found our grams of water and our grams of anhydrate. Okay, so we divided each of them by their mass on the periodic table, got their mole ratio. Once we had their moles, we put them in a ratio of water divided by anhydrate. And so I took the moles of water divided by the moles of anhydrate, and I got a multiplier of 1. That means that when I go to write my formula, it's going to be my anhydrate, CuSO4, with 1 H2O. If this had been a 4, we would have put a 4 here. If it had been a 3, we'd have put a 3 here, H2O. Copper 2 sulfate is the name of my compound. Monohydrate because there was only 1 H2O. If this had been a 2, we would have said dihydrate. And so that's the formula of a hydrate. So let's take a second and let's just go over our questions. We know the difference between a hydrate and an anhydrate is the hydrate has the water in the set ratio. The anhydrate is dry with no water attached. What is the mole ratio needed to determine the hydrate? You need the moles of water divided by the moles of anhydrate. Water divided by anhydrate. And how do you name hydrates? Well, we know that in order to name hydrates, we're going to use the prefix based on the mole ratio number that we got. So if we get a 2, it would be dihydrate. If we get a 3, it would be trihydrate. Usually you don't get anything higher than, say, a 6 or a 7. This should now help you complete your formula of a hydrate worksheet.